Hello.
Good morning or good evening.
Yeah, very good morning. Yeah. So, are you ready? All set?
Yeah, I just need to let me put my slides up just so I can make sure that I can share them correctly because I'm in Google Meet and I'm usually on Google Teams. So let me just let me see if sharing that works. Okay. I don't. It's not letting me share my screen. Let me see.
No. You have all the
What's that?
you have the rights to share it.
I know it's just not letting me do it. It says are there screen recording preferences happening?
Yeah, all are watching you live right now.
Okay, I think that's the issue. There's a screen recording issue and there's a permissions thing. So 1 second. I don't usually use Google Meet, so um, let me make this into a PDF really quickly and see if I can't do
Sure.
it that way. Give me
Yeah.
one. Okay. Just take a minute 'cause it's a big file. Okay, let's see. Okay, let's see if this is better and then I can share this. Okay. Now I have the presentation in PDF and it's up. So let's try that one more time. It is not letting me share my screen. Okay. How do I get this to? Do you want me to send it to you and then maybe you can share it?
Yeah, that's fine. You can share me in my official mail ID so I can.
Okay. Let me respond to your. Which email would you like me to use?
Yeah. Yeah. Contact at.
Yep. InnovaWorld. Okay.
Yeah.
Okay. I'm gonna send it to you now. There must be a permission setting between my browser
All
and
right.
Google. So sorry, it's a system I don't ever use. So I'm always on Zoom.
It's fine.
Okay, so it's coming your way. Did it come through?
Not yet.
Oh goodness. Okay.
Let me just finish it once. Yeah. Now, yeah.
Great. That's step one.
It's in PDF, right?
Yes, it's a PDF. I just sent you a PDF. I thought that was easier.
Fine. All right. So, okay. So, all set. Just a
Okay.
second.
I can't see it, but maybe when you share it, I'll be able to see it.
Right. So, let me just share the screen. Is it visible to you?
I see it now. It's coming up.
Yeah, just a second. I think some error from my side. I can't see it. Just a second. Let me
Yeah,
just.
it's showing, and you may be able
Yeah.
to put it in presentation mode so that it doesn't show the sidebar. Ooh, now it's like a hall of mirrors. That was cool.
Okay, I think now it's visible.
Okay. Yeah. If there's a way to get rid of that sidebar, great. Otherwise, because it'll make the slides a little bigger for people. Um, otherwise,
I think it's better. I think it will be visible to all.
okay. All right. We can go back to number one then.
Yeah.
Perfect. Okay.
Alright. So
Yeah.
before starting, so we will have a formal introduction about this today's event. So that over to Bhavneet first.
Okay. I'll just follow your lead.
Good evening to one and all. I'm here today to share some importance of the Space Week, which we are celebrating in the first week of October. So, space is a vast, seemingly infinite expanse that exists beyond Earth's atmosphere, encompassing everything from planets and stars to galaxies and cosmic phenomena. Space Week, often celebrated around the first week of October, is an annual event aimed at promoting interest in space exploration, science, and technology. It coincides with the World Space Week, which is officially recognized by the United Nations and runs from October 4th to October 10th. This period commemorates significant milestone in the space history, such as the launch of Sputnik 1 on October 4th, 1957, and the signing of the Outer Space Treaty on October 10th, 1967. Conducting Space Week is a vital initiative that contributes to the educational outreach, global collaborations, and the pursuit of knowledge, all while inspiring the next generation to explore the wonders of space. The theme of this year holds a vital importance as we collaborate space and climate change. The theme, Space and Climate Change, for the World Space Week highlights the crucial role that the space technology plays in understanding and addressing the climate change. This theme emphasizes how satellite observations and data can help monitor Earth's climate, assess environmental changes, and inform policy decisions. Satellites provide crucial data on temperature changes, sea level rises, greenhouse gas emission, and deforestation. This information is vital for tracking climate trends and impacts. Space technology aids in predicting and managing natural disasters linked to climate change, such hurricanes, floods, and wildfires, enhancing preparedness and response efforts. The theme encourages research into new technologies and methods for combating climate change, including renewable energy solutions and sustainable practices. Addressing climate change is a global challenge, and space agencies and organizations often collaborate internationally to share data and resources. The theme promotes education and awareness about how space technology can mitigate the climate change, encouraging individuals and communities to take action. Overall, space and climate change undergoes the interaction of space exploration and environmental stewardship, highlighting the importance of space resources to protect our planet. World Space Week is a great opportunity for people of all the ages to engage with wonders of space and understand its relevance to life on Earth. At last, I would conclude it with the notion of we are all born with a divine fire in us. Our efforts should give wings to this fire. Thank you. Now, I would request Mrs. Ashwarya Dhara to take over the session.
Thank you so much, Bhavneet, for wonderful introduction about World Space Week and especially about today's theme. So, So all we are waiting for about the introduction and welcome about our chief guest of today. And we have today Dr. Jennifer. So today I'm going to introduce, it's my privilege to introduce about her before starting up the session. Dr. Jennifer has spent her career bridging the science with the human elements and strives to bring a synergic approach to her clients. She is a co-founder, president, and CEO of Advancing Frontier Incorporations, a consulting company providing spaceflight integration services. Previously, she was the vice president for products and chief of solution architect at Teledyne FLIR, and in her 20 years at NASA, she was the division chief in the Human Health and Performance Directorate, a branch chief in the Engineering Directorate, and associate director of Human Resources. She has received her BA in physics and her MS and PhD in aeronautics and astronautics from the MIT. She has authored numerous publications and book chapters in the areas of human factors engineering, human machine interference, and artificial intelligence, telerobotics, bioastronautics, and human system integration, including agency wide NASA Human System Integration guidebooks. She has also spent her 15 years of non-profit board experience, and she is currently acting as an advisory board of Women's Women's Aerospace Network. She is a STEM career mentor as well, and also an active speaker in the areas of human systems and leadership. Dr. Jennifer is also an entrepreneur running her own coaching company that provides integrative coaching for individuals and the team members, guiding them towards both personal and professional achievements. And now it's all over to you, Dr. Jennifer, to take over the session.
Thank you so
Thanks.
much. It's lovely to meet everyone. I'm glad you're here. So I don't, are we going to do questions at the end or as they come in? If you want to tell me if questions are coming in, we can do them in real time. So I'll leave that to you to tell me how you want to do it. And you've got my slides. So whenever you want to show the first one, we will get started. Please don't be shy. Ask questions. That's what I'm here for. Um, and when the slides come up, we'll get going. So while the slides are coming up, um, I'll start with a little fun fact about space travel that most people don't know about. Um, if I had to ask you what you thought the biggest challenge of going to Mars was, so I'd like to do this if we can. If there's a way for people to enter into a chat that you guys can take a look at or see, I'd love people to give me a sense of what they think the biggest challenge going to Mars is, and at the end, I will reveal what it actually is. Let's see how many of you can guess. So sending humans to Mars. What's right now some of the biggest challenges or the biggest challenges in sending humans to Mars? Let's figure that out. Okay, I'm glad to be here with you all. I was honored to be asked to share a little bit about what's happening in space today and kind of where you all can position yourself for future careers. So let's move to the next slide. I'll share a little bit about my history with you all. And I'll talk a little bit about that more as we get to the last slide where we're going to talk about some career advice specifically for you all. But my bio has a little bit about me already, so I won't recap all of that. But I wanted to highlight a few things that I think are helpful for you all as students. So, um, I say this on the last slide, so spoiler alert, but no space career, no career in any field is a direct line. It's nice to think we all go to school and then we get the job in the exact field and then we step, but typically doesn't happen that way. And the journey is what makes it fun. So on this slide, I just shared some fun photos of my career. I have been in a lot of different fields. I was a physics major in college. I switched to space because that was really where my heart was going to space. I studied humans and automation and the relationship between humans and automation and machines. So basically, understanding how humans operate how we take in sensory information, how we decide how to make actions and thoughts and behaviors, and then what happens when you put that human in a very stressful or unusual environment. And that was exciting to me. So when I got to NASA in grad school, I was asked to do an internship down at NASA, helping build this humanoid robot that you see there on the bottom right, excuse me, of the pictures. And they had a lot of engineers who did software and hardware, but they didn't have anybody who really specialized in the human relationship piece. So that's where I came in. Over my career, I've done all the phases of development, designing, building it, testing it, fielding it, fixing it. I've done software, I've done hardware, I've done human. And that's really given me a broad set of skills to take with me to just about any field. So I definitely recommend you all think about where you'd like to play in that arena, and do it all if you can. I've been mentoring and doing STEM engagement and speaking since I was in graduate school and even in undergraduate. So it's always been a passion of mine to help the next generation. I've managed science portfolios. I've worked on every major space flight program up to date, starting with the shuttle at least, in my lifetime. And I've done a lot of leadership and training and development courses. I worked in HR for a little while to try my hand at that. And I loved mentoring and sharing and developing students and individual contributors so much that I actually turned it into a business on my own. I've also run branches in avionics and engineering with humans. And then I moved out into the corporate world, and I didn't know anything about corporate. I had worked for the government for 20 years, so I was completely new at it. And I learned a lot about what it means to try to build something for profit, which was a very different model than the government. And learned a lot about how we get products out into the world and having really that global team, which is I had a global team distributed all over, and we were trying to put together a whole ecosystem of technology, which is really what we're trying to do right now on the planet with space. So very exciting time. So let's go to the next slide, please. Okay, I want to highlight for you my passion, because it's going to run as a theme through my whole talk today. And that is human systems integration in space exploration. And um, there's a real importance to understanding how humans throughout the mission really guide the outcomes, the performance, and the cost and sustainability of a mission. So, humans we think of as oftentimes the operators of a system. We don't really think all the time about how many humans it takes to run a mission. So, the pictures you'll see here, the little one on the bottom, is what the pretty mission control picture looks like. Everyone's sitting neatly at their desks and staring at the big screens, and it's very organized. And then that probably is a good 50 some odd people. Behind the scenes, I don't know how far back you can see in that other picture, are another couple hundred engineers in the back room. And that's just one engineering back room. That's the back room for one of those desks in the front room. So to give you a sense of the scale and the size of the village it takes to pull off a mission, it's enormous. And so I want you to understand today just how many places there are to impact and influence and engage with space missions, space technology, space development, and even for satellite missions, which I know India is really very big into reducing the cost and developing in house tech for satellite missions, robotic missions. We all need to think about the humans it takes to run those missions as well. But more than that, um, what I want you to think about today is how you can redefine in your mind the idea of what a system is. A lot of times we think about developing a system and then we hand it to a person to go use. I want you to think of the human as part of the system that you're designing for. And that's how you're going to be able to catch all the things that are important about taking an idea and bringing it into fruition. Even if it's a satellite where there's no human in space with the satellite, there are hundreds of humans who are going to be touching that system, from design to build to test to operating it. All of those humans are part of what you have to design around. And I'm going to show you as we go on where that can run aground if we don't do it well. And then humans make space exploration complex, right? When we fly humans places, it gets much more complicated and much more expensive. But right now, more than ever, we are globally unifying our efforts to go to space, and it's really exciting. We've had a smaller number of players in decades past, and now it's just expanded And it's very exciting to see how everybody can contribute to this mission. But then we have to think about how do we do that well. So let's move on to the next slide, please. Okay. So I'm going to spend a couple slides just chatting with you about some current things going on in the area of spaceflight, and then sort of some lessons and challenges that we've learned as we think about going forward. So first, state of the practice right now, we are in a new era of space exploration for sure. No longer is it just a government entity flying somebody into space. Now we have commercialism, and we really need to look at sustainability in space flight and cost effectiveness. And how do we get access to space for everyone? So, for example, India's space program, which is driven by ISRO, is renowned for its cost-effective missions. And, the reusable rockets that SpaceX put together in Falcon 9 reduced the launch costs by 40 to 50%. And you can see the numbers there. And the Chandrayaan only cost $75 million. So when they're moving on to the lunar sample return, that's going to be also incredibly cost-effective by the way that they're moving forward now. You are getting cost efficiencies in leveraging in-house tech, in making cost-effective engineering decisions, very precise mission planning. All of these things are really important in creating a system of hardware and software and humans that can go and be sustainable in their mission and perform the way that they're supposed to. And India's launched over 300 satellites for various countries. And so very competitive pricing, very high reliability, very important as we are moving again to global service providers in the commercial world. AI and automation, we know we talk about this a lot today, and it's changed very, very rapidly. When I was first hired at NASA in 2000, we were building very early versions of AI. And that was in the robot that I mentioned to you earlier. We were already understanding how that was going to look and help offload the human of some of the jobs that we called them dull, dirty, and dangerous. What could we give a robot to do that then would allow us humans to go and do something that was more cognitively complex or requiring of our unique skill set? And so it's already playing AI a crucial role, spaceflight, comms, navigation, rocket landings for SpaceX, are automated, algorithms for communication, orbital adjustments of satellites in orbit already. They're also using AI a lot to analyze big data. So we get all of this information about Earth observation, space observation, and how do we take that data and process it and analyze it and really yield information that we can act upon for our Earth and climate change issues, for example. And that allows us to also make real-time decisions. NASA's flown AI assistants. We've been trying to develop those for years in various ways. And how can that AI assistant move from more than just someone who helps you with your task, but to someone who you really feel like someone, I've already made it into anthropomorphized it, but into something that a human would want to interact with and feel better about their day after they interacted with this AI. And you can tell now with ChatGPT and OpenAI how they're actually building in voices and personalities and sarcasm and all of these things. So that human interaction element is, again, very, very important. And then lastly, the global collaboration. We've already had a very strong history of collaboration across countries in space. And now with missions like Artemis, where we're having more and more countries build segments of that mission architecture, it's more important than ever that you all think about how to solve problems globally. Okay, we'll move on to the next one. And this highlights a little bit of some of the new emerging technologies in space. There are many, and so I didn't include all of them, of course, but here are some that I wanted to highlight for various reasons. First, I wanted to chat a little bit about nuclear propulsion. It's a very exciting new development because, of course, it allows faster travel to planetary bodies, to Mars, beyond. And it also forces us to think about long-term human survival. And interestingly, we often give a lot of attention to radiation when we're out in space. And so the promise of nuclear and faster propulsion, whether it's electric or ion propulsion, laser, we are looking to see how can we reduce the exposure of the human to the harshness of the space environment. And what it turns out is that as you shorten that trip time, you now have to turn your attention, because likely what they're going to say is, well, if we can get there faster, we can go more often, or we can stay longer. or we can send more people. So when you do that, now you've opened up a whole bunch of other new types of risks to humans. And so we have to think about, when we make technological advancements, what are the counterpoints to that? What new and emerging issues have we now created? So you hear us say a lot of times in the business, when we talk about automation and AI, for example, AI doesn't, or in automation, they don't solve problems um, and just close them down. What it does is it usually closes one set of problems, but it opens up another set. We have a lot of unintended behaviors that people engage in when we put a new piece of automation or a new AI system in play. So, for example, ChatGPT, the ways in which humans decided to use that were far beyond what the designers had intended, first of all, when they put it out. Same with this kind of technology. So, as you introduce new tech, what is it that we're now creating some new issues around? So, always be thinking, when you are all innovating and developing, okay, this will solve this set of issues, but am I creating any other issues that I also need to address? So, something to think about. Global investment, I've touched on a little bit, but if you didn't know, the global space economy is expected to reach $1 trillion US dollars by 2040. And the Chinese and Indian and US and Russian budgets are growing very quickly, JAXA as well in Japan, ESA and the European Space Agency as well. Private companies are putting a lot more money into, as you know, commercial access. And so, with these commercial agents kind of racing to develop tech for lunar bases, space tourism, it's going to start blurring all the lines between public and private, and everything really is going to become sort of a togetherness mission. And that brings up some issues around, how do we put policies in place? How do we put regulations in place? What do we need to manage across these countries who operate differently, have different cultures, have different abilities to support monetarily? And so, really interesting new emerging areas for you all to think about in terms of how this growth impacts us. And so, that last part there, we do have gaps right now and questions about ownership, safety standards, policies, who owns what that's mined on the moon. Where do we collaborate, and where does competition come in for fair market share? We really need international regulations on all of this: mining, satellite use, space, and everything. So, the global investment in space is enormous. All this emerging technology is, like I said, creating new opportunity, but it comes with a whole host of new challenges, which I think are going to be very exciting for your generation to work on. Okay, let's go to the next one. Okay. I've touched on this a little bit, but let's talk about the responsibility of innovation. That's kind of what I was alluding to on the last slide. So, mini sats are fantastic, especially when we talk about space and climate. CubeSats, for example, have really expanded the possibilities for Earth observation and communication. And that's incredibly exciting. We're getting more data than ever before on what we need to learn to really protect our planet. It also allows space to become more accessible for developing nations, for private and smaller companies. And so, this is what's driving all these new applications in climate monitoring, disaster management. And we know, certainly in the US here, we just got hit with Hurricane Helene. We have another one coming. And as these are more and more rapid and more frequent, how do we really rally the support that's needed on the planet? It also provides a lot more global access when these get smaller. So, satellite technology programs are really growing in popularity, especially in your universities where you are now. It's one of the most popular majors, and those majors are teaching you all how to focus on building hardware, circuitry, propulsion systems, the satellite itself. They're also teaching you all how to operate. How do you manage a satellite mission? How do you ensure the communication is successful? How do you acquire the data from the satellite, and then what do you do with it afterwards? How do you monitor all of that flow? And then also, these curriculums are very much interdisciplinary, because you're looking at, say, electronics and computer science and aerospace engineering to really get a holistic and comprehensive sense of what the technology is required to go do and operate to complete its mission that you've set out to do. But with more satellites, as you can see from the photograph, comes a really big issue, which is space debris. And I don't know if you know this, but space debris is actually the legal responsibility of the country that has launched it. And so that is now a new sense of global accountability that we didn't have before, when it wasn't a real issue. It didn't impact our missions. We were like, it's, it's okay. People didn't really give it much thought. But now countries are understanding that we do have a responsibility to what we put up into space and how that does impact future missions and operations. So that accountability is going to be interesting, and how, even if you created a sense of accountability, how do you enforce that? I leave it to you all to kind of help us figure out, what do we do when we have somebody who has put a lot of debris in space and can't or won't pull it down? What does that look like to have accountability, and so forth. So really interesting topic there to think about. And then I also wanted to bring up interoperability and resilience. And these are really, really very near and dear to my heart. Interoperability means that as we are connecting systems that were built by different companies, different countries, we need to have global technical standards that allow us to have commonality between interfaces so that we can use systems together. If you have ever seen Apollo 13, you'll know one of the more famous examples of that, when they had their accident and they had to go survive in the lunar module, the lunar lander. The air scrubbers, the CO2 scrubbers, were different shapes for the command module and the lunar module, and they couldn't just plug them in. They had to create on the fly some sort of adapter in order to allow that technology to work. We had that happen, unfortunately, very recently, where the SpaceX and the Boeing suits are not interoperable with one another. So we had an issue where we have astronauts stranded on the space station right now, and if there was an emergency, their spacesuits would not have plugged into the descent capsule that they would have had to be flying in. That's a real safety issue. You may remember, or you may have heard about at least, the Mars Climate Orbiter many years ago crashed into Mars because when they were programming it, they had people programming it from different parts of the world. Some people used English metrics, some people used metric, and some people used English standards, excuse me, and those didn't match. And so when the computer was trying to crunch the numbers, it didn't. They came out wrong and they crashed. So this is going to become a much bigger issue as we move more globally. And the interesting thing is, NASA has actually not put interoperability standards in place on purpose because they didn't want to stifle innovation. And so remember what I said to you a few slides ago, we sometimes put new tech in place to try to solve some problems, but it creates other ones. So how do we drive innovation? How do we allow companies and countries to really innovate fully and not stifle their creativity, but be pragmatic and say, but this is a lesson we really have learned multiple times. Maybe this isn't where we innovate. And how does that come across to someone who's trying to really think outside the box? So all of these are really interesting nuggets of behind the scenes that we don't often talk about openly. So that's why I wanted to bring it to you today, to start thinking about what it really means to work across borders, what it really means to work in international teams. And I really encourage you to start thinking about this. Resilience, I'll just mention briefly here. Resilience is, how do you not just be sustainable in your mission in terms of, say, cost effectiveness or mission performance, but the systems themselves that you're building. How do you build resilient systems? One of the common ways that we do this in the space industry now is redundancy. So you'll have more than one way to get power, more than one way to communicate, because those are so often the critical pieces of that operation or mission. Dissimilar redundancy is something we use to say, what if we had two ways to do it that were different? And so if it's the method that failed, for example, then we have something else to fall back on. So building systems that can work together and stay working for quite some time, to sustainability in the long term. Okay. And you already talked about the Outer Space Treaty in your intro, so I won't talk more about that. But we can move on. Okay. So I want to give you an example of some of the things I've been talking about that are important and what happens when it doesn't quite go to plan or when we don't think ahead on it. So back when the space shuttle was being designed and built, which is probably before all of your time, before my time too, actually, what happened was the picture there on the top is an artist's rendering, an example of what they thought it would look like when the shuttle came back from space and it was being refurbished and ready to go out again to its next mission. Okay. And the bottom picture is an actual photograph. It's hard to believe. It's an actual photograph of what that actual hangar looked like when the shuttle came back to be refurbished. And you can't see the shuttle, but I promise you it's in there. Okay. It's buried inside. You'll barely be able to see the front cockpit window if you squint and we blow that picture up for you. It's amazing what had to happen in order to take that shuttle and move it from readiness for one flight to move it for readiness to the next flight. So what happened and what's going on here. This is where human systems integration comes into play and interdisciplinary collaboration comes into play. So there were a lack of interface standards. I talked about the company already on the last slide, but what that led to for the shuttle is these teams where you had the people building the shuttle and designing it. And then you had over here a totally different team who were going to be maintaining it and operating it. And they weren't talking. Okay. So what was happening was they were very much emphasizing the performance of the shuttle. And they were not thinking about designing the shuttle to be maintained and to be turned around. They were like, oh, yes, we're going to turn it around. But they didn't design it for that purpose. They didn't have the operators and the maintainers coming in to say, well, here's what would be important to put into the design of the shuttle if you wanted me to be able to turn it around in a couple of weeks. Okay. And they also didn't define the operations very well. Like what is the concept for this? How is it going to come back? How long is it going to be in the hangar? What's going to need to be replaced each time after each mission? What only lasts one mission? Let's talk about it. Let's figure it out. Let's run through all of the scenarios and really define it so we get the right requirements. They didn't do that. And then the last thing is, this is a subtle point, but it's important. The people who were responsible for paying for the development of the shuttle were not the same people who were responsible for paying for the operations. So the people who were designing the shuttle could say, if it costs them more money to fix it later on, that's not our budget. We don't really care. So there was no incentive for the design team to build in cost effective maintenance for the next team because it was like, not our budget, not our problem, which is kind of what happened. So the shuttle was designed in principle, okay? They wanted it to be a jet aircraft hangar with 5 weeks to turn the shuttle around. They wanted it to fly 40 times a year with a fleet of 3 vehicles. And it turned out they needed that really elaborate scaffolding, large number of service workers required to, tons of people to do this, special tools, special gear, special crawl spaces. They only averaged 4 flights a year, not 40, okay, for this reason. So I want you to think about when we don't assume that we understand how the humans play a really critical role in not just designing it, but operating it and maintaining it, and we don't design for that, we are going to miss some very important technology and cost drivers. Okay, so let's move on. I want to share with you a group that I'm very passionate about that I hope you'll get involved with. And I'm sharing this at this point in the slides because we've talked a lot about what it looks like to collaborate across teams to really have those methods of communication and coordination and what happens when we don't do it well. So there's a group of us who have formed a new organization called the Organization for Space, Medicine, Engineering, and Design. And what we are trying to do is really bridge, and this is a global organization, so international involvement, the more the merrier. We are looking to make sure that the medical teams, the engineering teams, and the design teams are really working together to solve mission problems. And this is not just for NASA, this is for any space flight organization that is out there, a company that is out there. So our mission is to interdisciplinarily educate people. So I want medical technicians who are going to be designing my medical systems for space to understand the engineering impacts of what they're asking for. So if they said, I want an MRI machine in a space habitat, obviously the engineers are going to say, I don't have room for that. I can't do that. And then the designers are going to come in and say, well, how can we design this in a way that you don't take up an entire habitat with your medical equipment that you only need maybe once in a mission? So as an example, we're really trying to prepare folks for the future. This is, I hope, clear to you now that we can't do this in isolation. We need everyone to be communicating together in order to create really successful mission outcomes, whether it's a human mission to space or a technological mission to space. And we want you to be able to get involved in this. The roster of folks who have started this, I'm chair of the board of this organization. We have a really amazing and swift set of support around this organization. It's been quite wonderful to see. You can go to osmed.org and learn more. We do offer student memberships. We are going to be offering mentorship programs, hands-on learning. The whole reason we put this organization together is to help you all, your community, to really understand how to cross-train yourselves so that you have the most complete set of knowledge you can and really holistically can look at a problem and know that when you're solving a problem for space, when you're solving a mission that you're trying to plan together, that you do it with the help and coordination of everyone you're going to need to be successful. And we want to help you do that. So I encourage you all to check out osmed.org and become a student member. We are a nonprofit, and we have all the information on our website you can check out. Okay, that leads me to another organization that I feel incredibly passionately about and wanted to share with you all today. And so if we could go to the next slide. I'm also an advisor for the Women's Aerospace Network, as you might have heard in my bio. And the Women's Aerospace Network was founded by Hallie Pascal for the purpose of making space available for all. It is the fastest growing women's professional organization right now. And it has really taken off and hit a nerve because there have been a lot of women in this field for a long time who have felt underserved and underconnected with each other. And I want to be very clear, this is for all genders of support. We welcome every gender identity and every gender at all to please come and support this organization. And what we really want to do is make sure that we are sharing our vision for humanity that says we want everyone to be able to go. And one of the things that you may or may not appreciate, and this is where OSMED comes in and the Women's Aerospace Network comes in. We have changed, as I mentioned earlier, we're in a new era for space. We have been government focused for many, many years. And when that happens and you have an astronaut selection, you can pick the most healthy fit, the most high performing individuals on the planet to go and work in space. But now we're moving to say, how do we create space access for all, for everyone? Okay. And we have to be able to accept and train and fly and take care of and maintain the health and wellness of everybody who wants to go to space. And how do we do that? And how do we expand that access? We also want you to get involved in this. You can go online and read the magazine. You can contribute to a future edition. If you want to write for the magazine, please do. We have a strong online presence, so we're on Instagram and LinkedIn. And there's a podcast called Space for All. So we encourage you all to get your voice out there in whatever way you feel makes sense. Now, the next set of slides I put together based off of a post that Holly and her team did for the Women's Aerospace Network to highlight careers in space that most people haven't thought of. So remember that very first picture I showed you with the hundreds of people it takes to put together a mission. That's just the tip of the iceberg. There are more than just engineers that are needed to send people to space, to send technologies to space, to care about our planet and deal with climate change. So I want to share with you a smattering of different types of careers that you may or may not have thought of, just to highlight the variety of things that you could possibly do and still be engaged in the space community. Okay. So first, I want to highlight a space fashion designer. So you're probably wondering, is this really a thing? It is really a thing. We need clothes and garments for astronauts. We need them for space tourists. They have different needs. I just mentioned to you why the Boeing and the SpaceX suits aren't compatible. That's an issue that a fashion designer could actually work on and solve. We need clothing for inside the space stations, inside habitats, on the moon. We need them for launch and landing. We need them for the travel time. We don't have washing machines. We don't have showers. So the clothing needs to wick moisture. It needs to not smell, but it also needs to be functional and something you want to wear. So lots of things to think about. And there's a lot of advancing tech in terms of material science that makes this a really interesting field. So not just going outside the space station or the spacecraft or walking around on a planet and being protected, but even being interior and being protected as well. So, so tips, if you want to look at this, look at smart fabrics, wearable tech, and other textiles. The skills, we obviously can list some obvious ones here, but collaboration you'll see is a common theme across all these I'm going to highlight for you. Okay, next one. How about a space lawyer? This is actually quite an emerging and exciting field right now. So space lawyers are going to look at the legal challenges of space exploration, ownership of celestial bodies, ownership of materials that have been mined on surfaces, intellectual property. This is a really important issue. You talked about the Outer Space Treaty at the outset, and a lot of countries have signed the Outer Space Treaty, but as I mentioned earlier, it's right now not enforceable. So how do we deal with that? The skills that you're going to need here, obviously some legal skills, negotiation and diplomacy is a huge one. Multiple languages might be helpful, regulatory knowledge, and obviously very good communication skills, not the least of which is being able to clearly articulate complex legal and regulatory issues to non-experts in the law field. Okay, being able to really communicate your specialty outwards to people who don't have your level of expertise. That's also a common theme. Okay, stay up to date if you're interested in this on what's happening in the space legislation world, any career that you're interested in. Make sure you have a way to stay connected to get information on what's the latest and greatest so you can stay on top of it. Because sometimes university curriculums, as great as they are, sometimes are even behind the curve on what's happening outside the college gates. So keep an eye out. All right, next go. Okay, next one we have safety and mission assurance. So this is a really important aspect of any product or service. This could be terrestrial. This doesn't have to necessarily be space. But the idea here is, are we creating safe products and services? And how do we assure that it's actually going to meet the mission that we intended it to meet? So I can build you something that meets every requirement and it still doesn't actually do the job I intended it to do. So just be aware of that. We talk a lot about verifying requirements, making sure you check the box and you did that requirement. But that doesn't mean that the whole system is going to act the way that you intend. And so that's the really important part of mission assurance, as well as quality control. Is what we're building, manufacturing, machining, putting together, and testing, and getting ready to fly, is it ready to do its job? Okay, is it qualified to do it? So there's risk management in here, data analysis, very, very attention to detail. And what they're also looking at is the protection, not just of the spacecraft, but of the crew and the equipment and the engineers, right, who are there to help prevent failures. And I want to share this with you. A lot of times you will hear that it's human error, right? The human had the problem. They made the mistake, the operator, the pilot, whoever. And I want you to remember that the person in the cockpit or in the spacecraft or in the car or whatever the person is operating, whatever device they're operating, they are compensating for every single error or mistake that was made in the design, the concept of the build, the manufacture, the testing of that item. Okay. So any mistake that was made along the way is baked into that system already. And that human operator is knowingly or unknowingly compensating for all of those. So it's a challenge. And these folks really have a big job to do to make sure that we make those systems as safe and operable as possible. Okay, next one. Okay, this next one is public affairs. So if you like to speak and you are engaging and you have good communication skills, I highly recommend you think about being a public affairs specialist. We have to have people who can explain what's going on to the general public. And more than that, I really want to point out public opinion and public support for space missions, even if they're based for Earth benefit, has waned in the past many years. The public has not really been as engaged in space flight. They think it's kind of routine. It's not that exciting anymore. And ironically, now is kind of one of the most exciting times that we've ever had in space exploration. But public support is critical. And so being able to explain to the public, why is this important? Why should you care? How does it benefit you? Why do you want to get engaged? That is a key component of this type of a role. Okay, let's move on. I've highlighted also on this last slide here before we get to my tips, just some emerging trends to think about and to play with in your mind. So what's next? A lot of things are next, but hypersonic travel is very exciting, promising faster travel on Earth. We've had this in the past, but let me give you a little interesting anecdote about why requirements writing is so important that I mentioned earlier. So we used to have the Concorde that would travel very quickly around the globe, but with the sonic boom that it made, the regulators said that's too loud. We can't have that over land where people are living. It's too much of a nuisance. So you can only fly over water because no one's going to be bothered if you fly and make loud noises over water. But that really limited the number of routes that aircraft could fly. And it wasn't economically feasible to keep the aircraft in flight and in service for that limited return on investment and revenue. So it closed the program. The problem is the requirement that they wrote said you can't fly faster than Mach 1. That was the requirement that the government has right now still. So it's stifled innovation in aviation for the last 40 to 60 years because the requirement says you can't go faster than Mach 1. But that's not really the problem, is it? The problem was that it was too loud on the ground. So what if you made the requirement a noise requirement and said you can go as fast as you want as long as the noise doesn't get above this nuisance level? Well, there we go. That promotes innovation, right? So remember I said earlier that NASA hadn't been levying requirements for interoperability because they didn't want to stifle innovation. How do you write a good requirement that allows you to still innovate and not constrain and not miss critical issues of interoperability and development? So this is a perfect example of that. Space habitats. Lots of folks and companies are really excited about building space habitats for deep space, also for planetary. Artificial gravity is coming online. And so that's been an exciting adventure. In space manufacturing has really picked up in the last few years. So if that's a field you think is interesting, 3D printing, for example, and real-time tool making is one aspect. When I was at NASA, I managed the food lab, and we owned a set of equipment that was looking at how do we put vitamins and minerals into food in real time? Because once you put vitamins and minerals into food, it starts breaking down and it's no longer very effective for you. So you'd have to eat a lot of vitamins and minerals over a couple of years of a mission to really keep that efficacy high. And so 3D manufacturing could be part of that as well. So think outside the box. Okay, my last slide is going to be my kind of advice to you all, and then we're going to open it up for questions. I'd love to hear your questions, and I promise at the end I want to go back and see what you all thought the biggest risk of going to Mars was. Okay, so these are my tips from being in this industry for 30 years and being a professional coach. There are more than this, but I think this is plenty for today. First, I will tell you, be self-aware. Know yourself. Okay. Know what you like. Know what you don't like. Know what you're interested in. Figure out what you're interested in. Figure out what you don't like. Sometimes that's even easier. But understanding your own emotional connections with others and how you regulate yourself emotionally is really, really important. Understanding how you like to learn is also incredibly important. Learning how to listen is very important. Your career will run on relationships. And so building connections and relationships with others is what will make your career ultimately rewarding and fulfilling and successful. There are obviously skills like critical thinking, speaking, writing that you have to have and develop. Find mentors and role models. Right now, you don't know what you don't know. So be open to learning all the things, because if everybody knew what you were, if you already knew all the things, then it wouldn't be a very exciting ride. So just embrace the fact that there's so much you don't know. There's so much I don't know, and I've been doing this my whole career. But that's what makes it fun. Be your best you, but be authentic to yourself, because it's exhausting and not sustainable to try to put on a mask and pretend to be someone you're not, pretend to like something you don't, pretend to want to be in a job that you don't want to be in. So really follow what it is that you feel authentically is aligned for you. I also encourage you to think a little bit about the difference between judgment and discernment. You know, judging something keeps us a little bit more in negativity and says, well, this is either right or wrong against some experience or belief that I have. But discernment really lets us slow down and go, well, what do I want to think about this? Let me take a minute and make a decision and discern whether it's right for me or not right for me, or what I think about that before I make a quick judgment about something. Resilience, we talked about that in terms of engineering systems, but personal resilience is important, being able to sort of shake off the tougher days and keep going. And regulating your nervous system is a really big part of that. If you're staying stressed all the time, if you're stressed out by your classes and your assignments and your work, it's also unsustainable, and your health is going to suffer as well. So really being able to pull it back and go, okay, how do I reframe, regroup, reprioritize where I can put my energy right now? That is a superpower I want you to develop. And knowing your boundaries, knowing when to say no. I know it sounds like everything is exciting right now, and it is. And sometimes your capacity is exceeded, and so you need to say no to some things. But that leaves you the most energy for the things you really love and want to say yes to. So think about that. My life motto is the answer is no if you don't ask. So if you're curious about something, you want to try something, I can't tell you how many times I created my own job because I asked, hey, how about if I went and did this? They're like, great, that sounds wonderful, fabulous. Just try. Be a yes and person, not a no because. So if you're in a room and people are tossing about ideas and you don't love someone's idea, rather than tell them what won't work about it, go, okay, we could try that. And then what about this other concern that might pop up because of that? We talked about that earlier in the slide deck. Planning is great, but be in the present because that's where your power is, and that's where all the things, the magic happens, is in the present moment. And I want you to really enjoy your journey and pay attention to it, and not wonder kind of what happened and how did I get here. I already said this: nothing is linear or direct. It's just going to be a meandering path for you, and that's going to be really fun. Failure is just information. Go take advantage of all the opportunities there are out there for you. Diversity of thought and experience always makes work more fun and the outcome is more exciting and wonderful. And be intentional. Be intentional with how you show up and how you bring your energy into a room and into a group and into a team. Be very intentional, okay? But be ready to adapt. Get ready to pivot. Things are going to change and going to move. And lastly, stay curious. Be a lifelong learner. And if you're in a challenging conversation or situation, again, rather than snapping back to that judgment, go, well, gee, I wonder what made them say that, or I wonder what they're thinking, or I wonder what their experience has led them to say this, that, or the other. So it can save you in a lot of ways. All right, I'm ready to open. Do we have some questions and thoughts? And thank you so much for letting me share with you today.
Yeah. Thank you so much for and wonderful insights. We have a couple of questions over here in the chat box. Um, all right. So before that, let me stop sharing it.
Okay.
Right. So the first question that we have is, as we move towards lunar and Martian colonies, what role will satellite technology will play in supporting those missions, or is there any possibilities?
Yes, absolutely. So perhaps the easiest one to think through is the communications network that you are going to need. So right now we don't have a communication network, a GPS network of satellites around the moon, around Mars. And so one of the challenges is we can't navigate on those planetary surfaces like we can here because we don't have any way to get position data. So we're taking everything with us and doing it in real time on the surface. So GPS navigation would be incredibly important to have a constellation of satellites that could do that. Also, communication satellites. Interestingly, it takes longer for a signal to get from the Earth to the moon and back today than it did in the 1960s because we have more satellites that it has to bounce around, more computers it has to go through. And so, anything we can do to create more communication opportunities, because as you know, when you go around the backside of the moon, right, we lose connection. There's no line of sight to the satellite or to the spacecraft. And so we lose connectivity. So if we could regain that connectivity, that would be great. There will always be segments of space and time where even if you had satellites out there, it wouldn't you wouldn't be able to keep them in orbit enough to really do the job. So it needs to be around a surface or a body that we can keep them geolocated. And if that didn't answer the question, then ask me a follow-up.
Yeah, definitely.
Okay.
And we have another question. So, can you give a roadmap for achieving career in satellite communications?
Sure. So I would recommend a few things. So there's the technology associated with communications, which is very much changing rapidly. And that technology is developed here on the Earth, but it has to be able to be used in space. So, first, understand, not first, but one of the things to do is go understand the differences between how technology functions with gravity, with an atmosphere versus functioning without an atmosphere, without gravity, with huge temperature swings that you're going to get in space, right? All this technology has to be in space. So understanding the space environment is where I would say start with that. Then you need to understand the physics of telecommunications. What is it exactly that you're trying to build? What part of the spectrum are you working in with your communications networks, right? And so understanding the physics of that, and then understanding the sort of orbital mechanics of when you have something around a planetary surface, how is it influenced? What kind of propulsion would you need to keep that in orbit? How much could you miniaturize the technology so that it could You wouldn't have to have a large satellite devoted, because the larger you launch, the more expensive it is. How are you going to service and maintain that satellite once it's in orbit, right? What parts and components do you need to have? Like I mentioned, redundancy, resiliency. How are you going to make sure it lasts a long time? And how are you going to make sure that it's been tested thoroughly to withstand the environment? And how are you going to make sure that you can communicate with it? If the comms go down, is there another way to communicate with it and get the signal back? So all these sorts of things that we chatted about throughout the presentation are very important areas for exactly what you want to be doing. Does that answer the question for you?
Yes. So, as you know, let me ask one question from my side. As you know that gradually, soon the space tourism going to be a commercial one.
Mhm.
So, what is your take in that scenario? So, how we can make it commercial more effectively and sustainable mode? So, what
Mhm.
is your take in that?
So when I was at NASA was when we first let out the first commercial contract to let somebody else take someone to space or do something else in space. And I can tell you the mood there was everybody was very scared because they're like, I don't know what this looks like and what to do. And I was actually the human systems lead that they sent to SpaceX to help them figure out how to help us with that and how to do it because they'd never done it before. So my thought is a couple thoughts. First of all, when you're not working for a government and you have private funding, you have the ability to move much faster and you have the ability to innovate quite a bit differently than you do because the risk posture is different. What people expect of NASA and the amount that they're able to fail is much lower than what they expect of SpaceX or Boeing or Blue Origin or VAST. They're allowed to fail because they're just private companies and they're right, but a government cannot fail. So they can take risks that we can't. They can move faster. They can be more innovative in some ways. So the promise of that is very exciting. The caveat is we don't want these companies ignoring 60 plus years of good lessons learned, right? I pointed to some of them already. So there are places where innovation is great and there are other places where it's like don't reinvent this wheel, we've already figured this out. Right? So that kind of marriage of future thinking and past lessons, like that's the balance we're trying to strike. Do I think that getting everybody up to space is fabulous? Absolutely. Right? Let's get everybody up there if they want to get up there. I'm one of them. Right? So I think access to space is important, but it's a responsibility that these companies are taking on. What do we owe the population, the general population who we're flying in space? How do we take care of them? How do we make sure they're safe? How do we make sure that they can trust us? Or are we saying you can ride on our spacecraft, but can't promise you what the outcome is going to be? There are a lot of people who would still go. Some people would not, right? So we need to be very honest with the capabilities of these systems, the risks that we are exposing humans to as they go out into space. And the more innovative we can be, the more reduced we can make the cost of space flight, which right now it's not available to everybody except the very wealthy. And I'd really like to see that change. So.
And during your presentation, you have mentioned about human error. So, as when we are taking any passengers involved or human involved on flight, so that play a very vital role. So, what is your take in that? So we can reduce the human error.
Okay, great question. Um, there is some very interesting data. I'll use aviation as an example because aviation has been around a lot longer than spaceflight. Okay. You can look up the number of times when a human error in the cockpit caused an aircraft to crash and somebody to lose their life. Okay. We're kind of like a person, a death incident. Okay. There's data for that. It's not very often, but it happens where somebody made a mistake. Okay. And something crashed. 200 times more than that number is the number of times a human actually saved the day where an aircraft didn't crash because of something they did. Okay. So your pilots are working very hard for you to make sure that they land that plane and they take it off safely, right? Take off and land safely. And they, again, like I mentioned, they have to compensate for all the mistakes that everybody else made all throughout the design. Okay. Um, the most unfortunate incident of that is the Boeing 757 Max, where they had the crash. A lot of things led to that. We did a lot of studies on why that happened. Okay. One of the big challenges was they wanted to create an opportunity to get more power to the aircraft by changing the engines. and they knew that would change the way the aircraft flew. But rather than retrain all the pilots and have to recertify the whole aircraft, they said, what if we just put in some automation so that the pilots only had to do so much and they wouldn't have to worry about the changes that we're making? By not telling the pilots, by not informing them, by not training them, by not recertifying them all, okay, what it led to was the pilot didn't understand what the aircraft was doing, and it led to deaths, unfortunately. Okay. So, what I want you to know about human error is it is almost impossible to design human error out of a system. Okay. If I can design the safest aircraft in the world, the safest lunar rover in the world, the safest car in the world, I can still drive it off a cliff or crash it into a crater or plummet it into the ground, right? I, as the human, can do things that overcome, okay, the automation. One case of that is the oldest form of automation that there is, which is a horse. You almost can never get a horse off a cliff. They are going to preserve themselves, right? Like, right? They were like, nope, I'm not going off of there. I'm going to throw you off, operator. I'm not going to let you do it, right? So,
Come to that. Right.
right? For the rest of us, though, there's only so much you can do to prevent human error, but there's a lot we can do. And what that means is we have to be very careful about the requirements. We have to understand what we're asking these systems to do. How do we operate? What is the operations concept? And then make sure we have an understanding at every point how that human is going to be able to operate and use that, and then make sure that we carry that same standard and quality throughout the build, the tolerances, the manufacturing, the testing. We have to hold that to a high standard so that we're not influencing. The other thing I'll mention about that is errors are not just about the technology. Okay. They are about the culture, the supervisory tone of a company, right? So Boeing, for example, who's under the gun a little bit, NASA has a culture too. Every company has a culture. Your space agency has a culture. How does that culture positively or negatively influence people making errors? So, for example, when the American astronauts died in the Challenger explosion, the day that it exploded on orbit, on the way to orbit, there was a lot of pressure from the government, from the agency, from the president's office to launch because it was a public event. The president was going to be there. It was the first teacher in space. We had built this up. So even though the engineers were saying, we're not confident, they were like, it's okay. We're going to do it. Right. So there was an overriding of the errors. Ultimately they said it was an error in human judgment. Yeah. But because there was huge political and cultural pressure. So every layer of the organization needs somebody like you asking, how do we make sure that we're not creating an environment where making these errors is okay? Okay. Boeing had an environment where it was okay to not do all this extra work and just try to make it a little bit simpler. And that led to a big issue, right? And a lot of companies have been guilty of that. It's a really difficult lesson to learn, but it's all through the organization.
Yeah. Yeah, excellently explained about the scenario because when we create any flying vehicle, that will be involved with some sort of human error, but it's like how we eliminate those problems. So you have nicely stated, and we have few more questions from the participant. And yes, very interesting question. May I know how can we get into NASA being an Indian?
Yes. Okay. So unless you have US citizenship, you cannot become a civil servant employee of NASA. Okay, so civil servant employees of NASA are government employees, which means you have to be a US citizen. However, at the space center I was at, there are 10 space centers, okay, that NASA has all over the country, and they all specialize in different things. So first, figure out what kind of work you want to do. So I was at Johnson Space Center because that's where we did the human work. If you want to do Earth observation or you want to do propulsion, you're going to be at a different NASA center than I was, okay? And at my center alone, there were 3,000 civil servant employees, 15,000 contractor employees. Okay. So far more people walking around a NASA center work for a company that is not the government, but they still get to work sitting right next to me doing the exact same work. Okay. But they are not badged by the government. They are badged by a company. So what you can do as an Indian student is go and find out what kind of work you want to do and which are the companies that provide contractor workforce to that NASA center. So it could be like Lockheed, USA, Wiley KBR. It could be and those are just some of the ones for human spaceflight. For example, you can go online to like Stennis as a NASA center at Stennis. It has a list of the 15 companies that provide employees, and you can apply to work through any one of them. So definitely go look up being a contract employee. But even as an international student, you can still do internships. Okay. So even though you may not be able to get fully employed by NASA, you can do internships at NASA. So online, if you just look up, if you Google NASA internships, there's a page devoted to it, and it has all the information for national and international students.
Yeah, actually, to ensure about that, I have gone through that NASA internship page. There is a dedicated website. In that website, like there are a few countries has been enlisted over there. Only
Mm.
those particular countries can get into this NASA internship. So where I've seen that India is not there.
Okay, so then that's interesting. I would. So then that's a question. I know who I could ask about that. So that is that's a legal question. So what typically can happen is legal has a list of countries that are allowed to do sharing, and I
Yeah.
don't know what the agreements are between the Indian government and the U.S. government. That's probably above my pay grade. So there may or may not be something that says we have not created an agreement that allows our countries to collaborate on these. A lot of it is because of the you have to legally be allowed to see the information related to a government program or project, right? So you're taking on some responsibility of the information and the intellectual property. And so they have agreements with certain countries, excuse me, that they've already done work with to put these agreements in place. It may be that there is not a trade act agreement or a sharing act agreement between the United States and India, which case some of you guys go out and write one as a policy member. But that may be in the talks. Actually, my very close friend works in the international relations part of NASA, so I will ask for you guys, and I will send you the answer after we get
Thank
off.
you so much. Thank you. And we have one kind of similar kind of questions. Is there any way to join NASA or SpaceX without being US citizen? And can someone work in such companies on work visa?
So the answer, so that the question about working at NASA is the same answer as
Yeah,
before. So if
yeah,
you want to work, yeah, next to NASA, go do a company. But I think yes, you can probably get a visa. I believe that there is, depending on the country, there's certain stands. What do you call it? Like a bar you have to reach about um, I have a skill set that someone else doesn't have, or there's a position that's open to international. So and that might be based on the type of work that it is. So for example, if let's say it's in spacecraft machine making, like you actually building rockets, like that might be open to international students, whereas something about like the computer software that runs the code may not be, right? So I don't know if they vary that based on the exact job title. In that case, I would go to the company that you're most interested in and see what their policies are. It's going to absolutely vary by company. Absolutely. So there's no one answer for that question, unfortunately.
yeah, yeah. And there is, I think, relevant question. There are any options for Indian to virtually participate in some sort of research work where we can learn and contribute as an international student?
Yes. So if you are, I'll go check. I'll take a look. I'll send you the links offline. Um, there are a number of ways that, so are they asking about research? Is that what the question was about?
Yeah, research. They want to
Okay.
do an collaborative research on like virtually.
Yeah. So I think today most opportunities have virtual components available to them, right? Where it's just no longer are the days where we all have to be together. So there are research grant opportunities that come out from NASA all the time that you can build a team and then you can go pitch to go and be on this research project. Um, and I think I will also ask one of my colleagues in the research group, because I used to manage it when I was there, but it's the rules have changed since I've left. They do a lot more now than they ever did when I was there. But there may be ways where you have professors at different universities who are working on projects for NASA that you want to be a part of. So maybe talk to your professors too to say, do we have any knowledge of any people who are already funded by NASA programs or projects to do research, and you want to get engaged in some of that? I believe that by law, I believe every time that NASA has an award or a grant to a research entity, it has to be posted legally. It's publicly available information. So I believe you can go online and see like what the grant research is, like the grants that are open, that you could apply to, and also you could see who's been awarded grants. And if you're a student who wants to do an internship with one of those that you think is interesting, I would start there.
Yeah. And the last question of today's session, we will take this question. If we have an US citizenship and we want to join as a NASA scientist, what sort of skills and qualifications that the NASA will be required for?
Okay. So if you're a US citizen and you're interested in research, the first
Yeah,
thing I'd have you do is go look, sorry, I need water.
yeah,
Go
it's
look
fine.
on the websites for the different NASA centers to see what kind of research they do. Like I said, some is in research in technology, some is in research in Earth climate base, some is research in Martian lunar terrain, So go find the thing that you think matches what you're most interested in first. Okay. And then it depends on what level of degree you have. If you're going to want to run a research program or earn research dollars or win grants, you're going to need a PhD. If you have a master's degree, then you can work on those projects, but usually the principal investigator will be a PhD. So it's not out of the realm as a possibility that as you are moving up in your career and you're gaining more degrees, if that's what you're interested in, that you can still be a part of those research projects. And so again, I would go and find out what research is being funded at that in that area that you really like, and then ask what the opportunities are to be a part of it. You can email them directly. The skills and qualifications that you need. Number one, it's reading, writing, and arguing, right? You need to be able to read a research paper, understand how the research was done, and be able to discern whether that was a well done study, not a well done study, right? What would you have changed? Do you agree with the methodology, right? So start to, that was fun. Start to really be your own investigative scientist, right? Like, how would I put this experiment together? Really, the journal clubs are great for that. Learning how to read research papers and get knowledge out of them is one skill. Being able to write very clearly. I don't care if you're the smartest person on the planet. If you can't tell me why your idea is great, I'm not going to buy it, right? You've got to be able to explain to me why your idea or your theory or your hypothesis is worth studying. That's really critical as well. And then people are going to want to see that you know how to work in a group or on a team. It is very rare these days that somebody is independently working on anything. So anytime you have an internship or an opportunity to go to get a job, working in a group or a team is great. My college summer internship, was in materials science. It had nothing to do with space technologies. I was doing stuff in a lab with petri dishes and pipettes, and it had nothing to do. But it got me the skills of working in a lab, being on a team, writing up an experiment, conducting an experiment, right? So there are some fundamental skill sets that underlie all research. Have those in the bag, and then you can get fancy with exactly what kind you want to go study. So get the basics down first and get good recommendations. Like I said, it runs on relationships, so go work your heart out, put all you've got into it, and get a good recommendation, and that will help you get on in your career as well.
So, if we want to collaborate a research with you,
Mm-hmm.
so will you be there to support us
Yes,
or
contact
supporting your
me.
students?
Contact me, and I can also I also recommend you all get connected to the OSMED organization. I recommend you look up on the Women's Aerospace Network. Contact me. I'm happy to do that. And tell me what you're interested in, so I know how to help you the best. Um, and then, do we have anybody who guessed what the hardest part about going to Mars was going to be in the beginning?
Yeah.
What did they say?
The part is that research work and to understand the system.
Mm. Okay. So yes, so I used to manage some of the parts of the research portfolio. There's a large sum of money that we set aside at NASA to research going to Mars and the hard parts of going to Mars. We have lots and lots and lots, to your question, of people who are paid right now to do research to help us figure out how to get to Mars. Okay. Most people think that the biggest problem with Mars is the radiation. It's not. That's there. We'll manage it. The biggest problem is two things. Number one, the food system. We do not have a food system that will last as long as we need it to last to send it to Mars before the humans get there. They can eat it for 3 years and then still come back healthy. We don't have a system that does it yet. Number two, biggest risk to Mars is the behavioral health and performance of the crew, the mental well being, the emotional well being. the teamwork, the collaboration, missing home, being human. Being human is the hardest part of going to Mars. Okay, so I encourage you all, even if you're working in satellite technologies, right, and things that don't have humans on them. Remember, there are humans at every part of the process of you designing and building a satellite and sending it to space and maintaining it and keeping it up there. So don't forget those humans. They are the ones that make it run, and they are the ones that drive up the cost, and they're the ones that make it complicated. But that's why we're doing it, right? Because we're the humans, so we want to be a part.
Yeah, thank you so much. I think you have answered all our questions. You have satisfied us, and you have also clarified our participants' queries as well. And thank you for being here for clarifying their futuristic view of aerospace in terms of career, in terms of opportunities, especially. And you have mentioned the critical areas as well, that where they can do the research, where is the loopholes and the ways out in their careers as well. Thank you so much for being with us. Yeah, and if you're visiting India, you must visit us as well.
Good.
So we are expecting you to visit here in India. We'll be happy to welcome you here.
Thank you so much, and
So,
please contact me.
yeah, and in future we are hoping to do an collaborative research as some certain areas you have mentioned, and already some of our team members already working on AI ML technologies in different sectors. So we'll love to collaborate with you and contribute on the research.
Great, and I will get you in touch with all the colleagues that I know who are doing that kind of work. So tell me, the more you tell me about what you're interested in, the more I can help you. So
Yeah,
best of
and
luck.
definitely, yeah, I have shared your LinkedIn ID in the chat box. So they will definitely contact you and drop you the questions. So please do respond and help them and guide them.
Sure will. I sure will. Thank you for the invite. It was lovely
Thank
to spend
you.
the time with
Bye.
you.
Thank you.
Good night,
Have a
everyone.
nice day.
Thank
Yeah.
you.
Bye. Thank you. So, thank you, participants, for your wonderful participation on this event. And as I hope you have all enjoyed this session and you have learned from this session as well. So, before leaving the session, don't forget to fill up the feedback form. As you know, it's a week program and your certification depends on that feedback form. So please do, before leaving the session, please do fill up the feedback form, and then you can leave. If you have any other further questions, please, in the chat box, our team has forwarded the LinkedIn profile of the of our today's guest. So please do communicate with him and do mention from which event you have mentioned, and you've you have came to know about his link. Please to give our reference, and hope to see you tomorrow again with a wonderful session. Tomorrow we have a re-entry vehicle opportunities and futuristic view. As today a brief of ma'am has given a brief of this hypersonic vehicle, so tomorrow's session is more about the hypersonic vehicles and futuristic approaches and the challenges that you are going to see in the future. So stay tuned with InnovaWorld Private Limited and hope you're enjoying this big session. Thank you all.